would like to start with is, what is redox? Well, redox is when reduction and oxidation occur simultaneously. And we can remember it because of the saying, Leo says Ger, which we all know already is loss of electrons is oxidation, and gain of electrons is reduction. So how do we know what's happening? Well, first of all, we need to review how to assign oxidation numbers. Remember that anything by itself, meaning Ne is by itself, is going to get assigned a 0. Br2 is by itself, it is not a compound, is going to get assigned a 0. So anything that is not in a compound, 2 or more different elements, is going to get assigned a 0. Anything else we have to figure out the charges on. So for example, NaCl, Cl is -1, therefore Na has to be +1. In H2SO4, O is -2 times 4 is -8. Your H is always +1 unless it combines with a metal hydride. That gives me +2. And if the whole net charge has to be equal to 0, because we know compounds are neutral, then sulfur has to be +6. Recall when something is an ion, so PO4, 3-, then our charge is not equal to 0, but it's equal to the charge on the ion. So -2 times 4 is -8, and this has to equal a -3, which means that the phosphorus has to be +5. Now there are some exceptions to the rule. One exception is when oxygen combines with fluorine in OF2. You know that fluorine is -1, which gives us a net -2, which means that oxygen had to be +2. This is the only time oxygen is +2 is when it combines with fluorine. Another exception to the rule is peroxides. Peroxides have the general formula X2O2. So in this case, if I had sodium peroxide, Na2O2, we know that sodium's a group 1 metal, it's +1, that gives us a net +2. So oxygen has to be a net -2 in order for this to be equal to 0, but there's 2 of them, so that means each oxygen is -1. This is the second exception. Oxygen has a -1 charge when it forms a peroxide. It has a +2 charge when it combines with fluorine. Other than that, oxygen is always -2. The other exception to the rule is hydrogen. Hydrogen is always +1 unless it forms a metal hydride. If I have MgH2, my Mg is +2, which means that the net charge on hydrogen has to be -2 in order to equal 0, which means that each hydrogen is -1. In LiH, Li is +1 and hydrogen is -1. So when hydrogen forms a metal hydride, which is a group 1 or group 2 metal with hydrogen, that is when it has a -1 charge. Other than that, it has a +1 charge. So I think that goes through the exceptions. So let's get back to loss and gain of electrons. I'm going to get rid of all this so I can continue right here. So loss of electrons, as we said, is oxidation. And what happens to our oxidation number? Well, let's look at one example. If I have Zn 0 going to Zn plus 2, this is a loss of electrons. When I lose, I become more positive. 0 to plus 2 is more positive. And I'm going to balance this oxidation half-reaction by adding electrons. I always add electrons to the side that has the higher charge. 0 versus positive 2. This is the higher side, so I'm going to add 2 electrons here. A positive 2 and a negative 2 give me a net 0, which now matches this. Now, it doesn't always have to equal 0. I could go from Fe plus 2 to Fe plus 3 plus 1 electron. So a positive 3 and a negative 1 gives me a positive 2, which also gives me a positive 2 on the left. So once again, I am more positive, because when I lose, I become more positive. Gain of electrons, okay? If I have Zn plus 2 electrons, this becomes Zn 0. So here I'm going from Zn plus 2 to Zn 0, and this is becoming more negative, because when I gain negative charge, I'm going to become more negative. I'm gaining electrons. Another example of this is going from O2 to O minus 2. Okay, this is diatomic oxygen going to regular oxygen. I need to balance my mass first by putting a 2 here. 2 times 2 is negative 4. So I have 2 oxygens, each with a negative 2 charge. So I'm going to add 4 electrons to the left here. So I'm going from 0 to negative 2. Once again, I'm becoming more negative. This is reduction. Now, we have to understand how to balance equations. If I had an equation such as Na plus O2 yields Na2O. So if I were to balance this, I would have to put a, let's see, I'd have to put a 2 here, and then I would have to put a 4 here. So let's look at what's going on in this reaction. This is 0, this is 0, this is plus 1, this is minus 2. So it's very easy to see that I've got Na going from Na plus to Na plus 1. This is my oxidation, and I've got O going from 0 to minus 2. This is going to be my reduction. So let's write half reactions. I've got Na0 going to Na plus 1 electron, and this is my oxidation. And then on my reduction, I have O2 0 going to O minus 2, and I need to balance the mass, so this is 2O. This is going to be 4 electrons over here. So negative 4 and a negative 4. That's reduction. Do you see how these are not balanced? The electrons are not balanced. So the only way that I can balance the electrons is by multiplying the top reaction by 4. So I have 4 Na0 going to 4 Na plus 4 electrons. And then on the bottom I've got 4 electrons plus O2 0 going to 2O minus 2. Now my electrons cancel. And my balanced reaction would be with what's left. 4 Na0 plus O2 0 yields 4 Na plus 2O minus 2. So let's talk about, we know it's oxidized, we know it's reduced. So what's our oxidizing agent and our reducing agent? Remember, our oxidizing agent is really the species reduced. So what was reduced? My O2 was reduced. Or reducing agent is really what's been oxidized, so that would be my Na0. We've gone over how to assign oxidation numbers. We've gone over how to, the difference between reduction and oxidation. We've gone over balancing equations, oxidizing agent, and reducing agent. In order for something to be redox, you must have reduction and oxidation occurring simultaneously at the same time. So one species loses electrons and the other species gains electrons. So electrons lost, okay, must equal electrons gained. What is a voltaic cell? A voltaic cell is also known as a galvanic cell, after the guy who named it. And it is a spontaneous reaction in which chemical energy is turned into electrical energy. It consists of two half cells. So you've got two cells with two electrodes connected by a wire and a voltmeter that measures electrical output. It also contains a salt bridge, and the salt bridge allows for flow of ions. If this is zinc and this is copper, there's a couple of things that we should be able to tell. First of all, you should be able to tell me that zinc is oxidized. Why? Because zinc is above copper on table J. So you can use table J to determine what's oxidized and what's reduced. We also know red cat anox. So we have reduction at the cathode, and we have at the anode is oxidation. So therefore, since we know that zinc is being oxidized, this is my anode over here, and this is my cathode over here. We have also now determined that the electrons are going this way, because we know that electrons flow from anode to cathode. So electrons flow anode to cathode. If I asked you to write some reactions here, what is it that you could tell me? Well, you know zinc is being oxidized. So when we're oxidized, we go from the metal to the ion. And when we are reduced, we go from the ion to the metal. So we can write some reactions here. We have zinc 0 going to Zn plus 2 electrons. And we have copper. Probably they would tell us something else. Like they would, it probably would tell us that this is ZnSO4 and this is CuSO4 over here. So we've got Cu plus 2 going to Cu 0, and we need plus 2 electrons in here, because your electrons get added to the side that has the higher charge. See how we did that? These are balanced. So our electrons would cancel, and our net ionic equation here would simply be what's left. Zn0 plus Cu plus 2 yields Zn plus 2 plus Cu0. Some other things that we know as this reaction proceeds, okay? One of the electrodes decreases in mass. So one electrode decreases in mass, and the other electrode increases in mass. And what you can do is use the half reactions in order to determine which one's doing what. So I'm going to go back to this and I'm going to read this in words. Zinc atoms, so Zn, zinc atoms turn into zinc ions, that's this part right here, by losing 2 electrons. So if the metal atoms are losing electrons and turning into ions, therefore the zinc electrode decreases in mass over time. Now, let's go to the other equation. So you have copper ions gaining 2 electrons and forming copper atoms. And your copper atoms, that's your solid, it's your electrode. Therefore, the copper electrode, I should have wrote this out as electrode over here, electrode increases in mass over time. Let me go back and correct that. This should be electrode. So that's basically the galvanic cells. Then you have electrolytic cells. So these are non-spontaneous. A power source is needed to drive a non-spontaneous reaction. So you're taking electrical energy, which is from the power source, and you're using that to make chemical energy. So it's the opposite of a voltaic cell. The other thing that you have to remember is you have 2 types here. You have electrolysis and you have electroplating. Electrolysis is used to separate a fused salt, and it's also used to split water. You have to remember that in electrolytic cells, electrolytic ends in C for cathode and begins with electro, which reminds me of electron, is negative. So you have to remember that the cathode is negative which means that the anode is positive. And then everything is opposite in a voltaic cell. So, for example, if I were going to split NaCl, the cathode, which is negative, would attract the Na plus ions. The anode, which is positive, would attract the Cl minus ions. So at the cathode, or at the anode, you have oxidation. So anode, because that doesn't change, is oxidation. So you basically have Cl minus forming Cl2 gas. So this is going to be 2Cl minus, that's a negative 2, plus 2 electrons. And then at the cathode, you have Na plus 1 electron forming Na0. So this is becoming more negative and this is becoming more positive. Electroplating. Most important thing to remember is the object to be plated is always at the cathode. So the object to be plated is at the cathode, and then the metal being used to plate is at the anode. So typically these are one cell. So if I have a beaker here and I have some silver metal and I have a ring attached to a wire here. So both of these are going to be hooked up to a power source, okay, which is going to be a battery. Here's like my 9-volt battery, okay? So this is going to be the cathode, which is going to be my negative, and this is going to be the anode. This is going to be my positive. So at the cathode, I have reduction, and at the anode, I have oxidation. So my oxidation half-reaction, which is, this is my anode, over here where the silver is, I've got Ag0 going to Ag plus 1 electron. Okay? Over here, reduction, remember that this is all going to be, electrons flow from anode to cathode. So my electrons are flowing this way and then this way. So this is going to have all kinds of electrons on it. And I've got all these silver ions in solution. So what's going to happen is they're going to be attracted to this negative charge. So for the reduction, I've got Ag plus 1 electron that it's picking up right there on the ring here. Well, this is all lined with electrons too, forming Ag solid. So the silver plates on top of the ring. Okay, last thing I want to do is compare and contrast. That's a really bad Venn diagram. Okay, so we've got voltaic and we've got electrolytic. And then we have the common area in the middle. So first of all, this is going to be Leo says Gur. And it's going to be red cat anox. Red cat anox. And the last thing that needs to go in here is that the electrons flow anode to cathode, A to C. Okay, for voltaic, it's spontaneous, and it's always going to be chemical energy converted to electrical energy. And the anode is going to be negative, and the cathode is going to be positive. For the electrolytic cell, it is non-spontaneous. I forgot something on the other side. I'll go back in a minute. Non-spontaneous. You need a power source to drive the reaction. Therefore, it's going from electrical energy to chemical energy cathode is negative, the anode is positive, and we need to know about the two types, electrolysis and electroplating. Over here, we needed to add that you need a salt bridge, and that's for the flow of ions. And this has 2 cells. And then we have a car battery, which is an example of a wet cell. And then a regular battery, you know, like for a calculator or a watch, is an example of a dry cell. Okay, that's it. I would definitely do some of the practice tests, go over the notes, do the other test to get ready, ask questions in class.